Well, hello everybody, and welcome back to the bench. As you can hear in the background, the furnace is going full tilt today. Had a cold front come through and getting some unseasonably cold weather the last couple days. I mean, it's right now it's 16 degrees Fahrenheit, and here it is November, not even the end of November, middle of November, early November, and we're getting this really cold weather. So forgive me if you have to hear that little noise in the background of the fan running from the furnace, but I can't turn it off because I don't want to freeze while I'm making videos. Anyways, this is going to be another part to our oscilloscope series. And in our very first part one of the oscilloscope series, we looked at what was a kit type oscilloscope, and it was made by DeVry Institute, if you remember, and it was an old vacuum tube oscilloscope that used a CRT, and it was assembled as a kit in that school. So I thought it'd be kind of neat to look at what a modern oscilloscope kit would look like today. So what I have here is just that. It's a modern oscilloscope kit, and this was given to us compliments of the folks at Banggood.com. They donated this to me free of charge. They didn't give it to me to do a review or anything. They just asked that I feature it on one of my videos. I'm not getting any endorsements or payments or anything like that for it, just the product, which I thought was very nice of them. I'll put all the links to to where you can get one of these if you're interested in building one. But I thought maybe we'd build one of these together and kind of see how it works and see if it's even usable for for beginning projects and so forth. So I thought it would be a fun thing to do and a fun thing to feature, and kind of try to compare how you built things back, in the 1970s or whatever, versus how we build things today. So yeah, this is it. So as you can see, the company that builds this, or that features this, is JTech, or I don't know how you pronounce that, JYE Tech. The model is model DSO-068, and the reason I liked this, they gave me a choice of different products that I could feature. The reason I chose this one is it was a little unique from some of the other low-cost little LCD oscilloscopes that are out there, in that it has a few extra features such as a frequency meter, and they were even talking about the later versions of firmware being able to do some things like FFT calculations and things like that. So I thought, that kind of piqued my interest. It is not a dual channel scope, even though you see two BNC connectors on there. It's actually a single channel scope, and then it has an output as well. The other reason I chose this is it's kind of neat the way they have the division, volts and so forth per division. It's kind of a little similar to how that vacuum tube DeVry scope was. Everything's very basic and simple to use, and this looked like a simple to use device. So let's open the box and see what's inside. Alright, so when we open this up, the first thing that they have is couple little documents. The first one here is going to be an assembly guide, and this is supposed to help us to be successful in assembling the kit. It lists the parts. It gives you little notes about the parts that have polarities and how they would be put together. Tells you what kind of tools you need. So you don't need a whole lot of things to be able to do this. So this is actually a very good beginner's project. This would be something for a student or somebody just getting into electronics. And when you're done, you have a piece of test equipment that hopefully we can use for some things. Comes with a parts list of all the components, and it just gives you, you know, a pictorial layout of, you know, kind of how things are put together. And you can see it's two-sided. It shows you, after you put it together, it gives you some ideas of how to adjust it and how to do some power-up tests for our first power-up, how to install the battery and so forth. So it looks like, even though it's one page, it looks like some pretty good instructions. Now we'll find out as we try to do this. The next document that comes with it is a user manual, and it just kind of lists all the different functions, how to get through the menus, how to select the different functions. And as you can see, here's some of the menu things. So yes, there's a frequency meter in it. Let me zoom in a little bit. I'm really kind of excited about some of the features that they're showing on this, if they really work. It does have FFT, fast Fourier transform. So technically we can look at distortion and things like that. It has, you can actually save waveforms, and that means that this is a digital storage oscilloscope, unlike some of the other lower end ones of these that are just a free run analog scope, and like our DeVry scope from our first oscilloscope video. This actually can do image storage, so that's pretty cool. So this looks like it should be a pretty interesting product. Now, when you take it apart, or take the box apart here and open it up, at first it seems like the only things you're going to assemble is just this little packet with these couple little boards. And you get a little oscilloscope probe with the witch's hat. Very nice. We get this little connector, a USB interface cable, which tells me that we can at least be able to program it or connect it to our PC, or maybe even it'll have a PC interface. I don't know, but I don't see any software with it. And then you get the actual device itself. I'll also put the link on the website down in the notes, you know, in the more section. There are several files you can download. You can download a firmware for this to reload the firmware. You can download the flash tool that will allow you to flash new firmwares onto this if they come out. And they have the instruction manuals and so forth in PDF form if you want to be able to look at them and print them out. And I've downloaded all of them. And I'll honestly tell you, I have not opened them or looked at any of them yet. So we're going to kind of look at all this for the first time together and learn all this together. And I just want to see how difficult it is for me to put this together. So we're going to actually do all the assembly on this. And, you know, for some people who are just getting into electronics and soldering and things like that, hopefully this will be kind of an educational thing and interesting. For people who are used to kit building or more advanced in electronics, this might be a little bit of review for you, or it may even be a little bit of boring. So you can kind of slide the progress bar on the videos you're watching if there's some parts that you don't want to go along, you know, follow along with us. So it comes with a little kickstand, which I kind of like that. And if we open it up, let's see here, you can see inside is where they store all the components. And you can see there's quite a few in here. So we have our work cut out for us. I don't know if the glare's getting you or not, but we're going to have to organize all these and go through them. You have the circuit board, and you can see all the surface mount components have already been installed. So the really difficult soldering jobs have been done for you already. And you can see that the encoder is in there, but there's no solder on it. So we'll have to mount that, you know, install it. Everything seems to be already marked. all these parts, these switches and so forth, are pushed in here already, but if you notice, they're not soldered, so we'll have to do all that. Now, the first thing I can see, this is the first time I've taken this out and looked at it. And my personal opinion, just looking at this, some of these little pads here are very small. So I think one of the things you're going to have to realize is that if you do have a soldering pencil type, you're going to want to watch what kind of tip you use on this, because a large tip is going to be very difficult to get into these tiny little pads. And the other thing you probably will want for this, and again, you don't, it's not a must, but you're going to I would recommend a temperature controlled iron for you doing this, because if you have just a soldering pencil that you plug in, like a 40 watt or 60 watt, some of those big ones, they get so hot that what will happen is they'll lift the tracks right off the board and damage them. So we're going to have to be kind of careful how we do this. There are lots of soldering stations you can buy online for a very reasonable price that are temperature controlled. I mean, obviously they're not super high end, but they're fine. They'll work perfect for you. And the thing is, you just want something that can just bring the temperature up to where your solder will melt and flow properly onto the board, but not overheat the board to the point where we're going to burn the pads. So we'll look at some of this stuff as we do it. I'll explain it as we go along. But you can see there's quite a few components that we're going to have to mount on there. There's the little carbon blister buttons, and those just kind of sit in there. They're already mounted. And then we actually have the display module, and along with that we have the header plug. And again, this does not look like it plugs together, so we're going to have to do this in a certain order, because even though, I've seen some of these with a header plug and a header socket, and they're nice because you can put the board together and take it apart to service it. These kits, these cheap kits, and this is not the first one I've seen, once you tack these all in, they're soldered on both ends together, and therefore you cannot take them back apart very easily once it's together. So if you put this on there and then realize you need to remove a resistor or a part or do some work on the board, you are not going to be able to do it very easily without really having some good desoldering equipment. So just keep that in mind. The order that we assemble this is going to be very important to being successful. All right, so here's all your parts, and it doesn't look like it's going to be impossible. I think you can all do this, and so we're going to start by sorting the parts out, and let's start the assembly. I've gotten everything out of the box a little bit here, and I have it organized, and I've kind of taken this insert out of the box, and I'm just kind of using that for the loose component, the big components. And the thing I'm going to focus on, first thing I did was I kind of just read over the instructions a little bit, just to get familiar with what they want us to do and how they want us to do it. And the first components you always want to start with when you're putting together a project like this are the low components, the things that sit flush to the board. The tall components will be the last. So you go from lowest to highest. And the first thing I always like to get out of the way, and it's just a personal preference, is the resistors. Because they're the smallest, and depending on your eyesight, and even if you have good eyesight, sometimes it's very difficult with how tiny these are. These are little teeny tiny, and there went one resistor. I'll have to go find it. These are tiny little resistors, and you can see looking at the colors of the stripes is going to be very difficult. So it tells you in the instructions even that you're going to want a multimeter to be able to read the values of the resistors. so that you make sure you're getting the correct resistor. Now, there's ways to do that. Obviously, the traditional way is to get your meter out, turn it on to ohms, pull out a resistor like this. Okay, there's a diode. And then you kind of try to just hold this and read it, or hold it down here and kind of touch it, and it rolls around and it's kind of awkward. So what I like to do, I don't know, maybe you guys have already done this sort of thing as well, is I just took a couple of banana jacks like this, and I took some stiff copper wire, just out of some house wiring. Really, I just had an end cut of house wiring that I kept, and I just cut a couple little 1.5 or 2 inch lengths, and I soldered it down into these little banana plugs. I didn't even put the ends on them or anything. And then that way you can put them in your meter like this, and you can kind of bend them open or closed as you need, and it makes a nice little test jig that you can take these resistors and just kind of touch them on there, and you know that you have a 10 mega ohm resistor. Now, if we want to look very closely at this, I get my magnifying glass. I don't even know if the magnifying glass will pick this up, but I don't know if you can see the colors, but if you look at the colors, it's, oh my goodness, I can't see it. I think it's brown, black, and green, which would be 10 megs, I think, or brown, I don't know. It's so hard to see, it's so tiny. But that's kind of the example of what I'm saying, is you really have to, and there, yep, and you can look down here, it tells you there are 10 mega ohm resistors in there. Right there, item number 13, 10 mega ohms. So, as you can see, I can't see these colors on here at all. They're too tiny, it's too small. So, I like to use this little jig, and you can just touch the resistor on the two little prongs. It'll tell you the resistance very quickly, and then you can mount your, get the component on the board and move on to the next one. So just a little tip, and again, it's just something that I do, in case you want to try something like that. Very easy to make, though. All right, so as you can see now, in the box here, I've just taken out what appears to be all the resistors. And of course, the parts eating floor got a hold of one of them, which I'm going to have to either find or replace. And of course, that's just me, fumble fingers. Nevertheless, get ready is the part that they want you to do. Complete the steps in the get ready and understand soldering requirements. And it says check the part values and the quantities against the parts list. Meter and identify the resistor values by ohm meter. So that's what they're talking about. And you can see here's our parts list. And the first thing that hit me here is, let's take a look at these resistors. If you notice, some of them are one size and they're kind of blue color, and other ones are a larger size and they're a green color. Now, those of you who are new to electronics, you may not know, these are not all resistors in this box. These green ones that are a little bit larger diameter are actually inductors. Okay, they're the little tiny, let's take a look here. I think there's 3 of them. These are actually inductors, and so don't confuse them with a resistor. If you put them on your ohm meter and you try to read them, let's take a look and see what they look like. They do read like a resistor. However, they're going to read very low ohms. So you look at this one, it's 3.2 ohms. But if you have a component tester that can check inductors, you'll find that it is actually not a resistor. Let's see if this thing will read it. And we'll put it into coil mode. And if we look, in fact, it is a 100 microhenry inductor. It's actually 98.1, but it's going to be a 100 microhenry inductor. And if you look down here on the parts list, make sure I don't lose another part to the part eating floor. If you look down here, there is in fact a 1600 or a 100 microhenry inductor. Can you see that? I hope. So the point is that those are not resistors, they're inductors. So I'm going to put those in the little bag also for later, because we're only going to focus on the resistors first. I always like to do that. They want you to kind of take these all out and take inventory and make sure that all the parts are present and accounted for. So I've roughly gone through most of them. It looks like everything is here except my resistor that I lost because of my fumble fingers. And now we can go through, and when we're ready to start mounting the components, we're just going to use our little test jig that we've made. We're going to measure the value of the resistor, just like so. And you can see that's a 180 ohm resistor. It says 179.2, but that's going to be a 180. And you'll find that when you measure these, they're not always going to be exactly the resistance that they're listed at. And again, if you look at the color code, I just don't think I can get this close enough and focused enough to be able to actually see it. But in fact, it'll probably be a 180 ohm resistor. Okay, so like I said, this is going to be difficult to see these tiny little 1/8 watt resistors, especially on the blue background. I like the metal film resistors. They're very durable, they're very accurate, they're very reliable type resistors compared to the carbon comp resistors of the old days, but they are much harder to read. So be prepared to use your meter, and just understand that standard value resistors aren't going to read exactly the ohms you're looking at. So that 180 ohm was reading 179. And again, I'm speaking to all of you who are totally new to using meters or to electronics that are just learning. When you identify components, don't worry if they don't read exactly what the instructions say. Okay, for all of you experienced electronics engineers, you all know that already. So let's move on. The next thing in our instructions, it says install parts by the order of the parts list. And of course we did the resistors first because they are first listed in the parts list. And again, it tells you what values you're looking for, and it tells you how many of each, and it tells you what location on the board that they're going to be. So we're going to take a look at that. And for instance, they're saying a 510K resistor. It's an 1/8 watt and it's 5%. And that little 5%, what that's telling you is when you put it on your meter and read it, it can be plus or minus 5% of that 510K. So that's what I was talking about earlier. Again, all you guys that are experienced, you all know what I'm talking about, but I'm trying to speak to those who do not. So we have two resistors here that are 510K. Now, you can sift through every one of these and find the one and put it in this order, or kind of the way I do it, since resistors are resistors, I randomly pick one up. I put it on my little tester just to see what it is. And that's a 2 mega ohm resistor, you can see. And again, don't use your fingers like that to hold it, because you can see it skews your results big time. Just hold it on one end like that. and you can see it's a 2 mega ohm resistor. And if we look in here, the 2 mega ohm resistor is item number 4. It's a 1% precision resistor. It's an 1/8 watt, and there are 2 of them, which is R2 and R4. So we can either put this resistor in R2 or R4. Now this is one of those more difficult kits to put together, in that even though the board is screened, it only gives you the designator for the component. As you can see, R22, R21, R20, and so forth, but it doesn't tell you the value. So the only way you're going to be able to do that is to measure the component. We know that that's 2 meg. We know, we went through all that, and we know that it's R2 and R4, so you have to look that up here. Then you have to go onto the board and kind of scan around, and you can see right here we have R4. See it? This is all very tiny, so I hope the camera's picking it up. So we're going to mount that component on there. Now there's a couple different ways that we can do this, and I'll show you how to do it. Now when we're dealing with components that are so tiny, you don't really need tools to bend the leads. A lot of the times the circuit boards are designed in such a way that the lead spacing is just barely larger than the length of the component itself. So you can see when I hold this in front of there, if I just folded those leads right over against the body of the resistor, I would pretty much have that bent at the correct spacing, that's the way we're going to mount these. So you're just going to take this and kind of just fold this end and fold this end, and it's simple. Now for larger components or components that have wider lead spacing, you can use your needle nose pliers and just, give it a fold, at the correct distance. Or the third way is you can purchase yourself a set of these. And what these are is bending jigs. And you can see they have different component body diameter lengths, and then they have different lead spacing lengths. So what you would do is you would place the component, and let me grab one here real quick for you. So you would grab your component that would fit inside there. You would choose the appropriate lead length that you need, and then you just fold it over the sides, and that would give you a perfectly crisp 90-degree lead spacing. So these can be purchased on eBay and Amazon.com and Banggood, and lots of other places have them, and they're very inexpensive. They're a couple dollars, and they're well worth it, especially for those who really want a professional looking component with the nice crisp bends on the leads and everything. So just another little tip there for you. We're not going to use those today. We don't need them because, like I said, we're going to just fold them against the body of the lead. And we're going to place this in R4, and then we have another one for R2 eventually when we find it. We're just worried about that right now. So you just press it in there, and you want it to be nice and flush with the circuit board. And then I always just kind of bend the leads just a little bit to hold it in place. Okay, there you go. Now let's look at a couple methods of holding the board. You're going to want a way to actually hold the circuit board, because it's going to get really awkward if you don't. These can be purchased a lot of different places. Harbor Freight sells them. You can get them from Amazon. You can get them from eBay. You can get them from Banggood. There are many, all the electronics parts houses have them. Very inexpensive. I think I paid $3 for this. And what it is just a set of alligator clips, or crocodile clips as you may call them, mounted to an arm that articulates. And all you do is just kind of clip it in there, and then it holds the board so that you can solder it in place. Now that's one inexpensive way to do it. It even has a little sponge for to clean the tip of your iron, and it's heavy, you know, metal, you know, cast metal base on it, so it's nice and heavy. So that's one way, and I highly recommend, if you're going to get into kit building or anything, to get a set of these. They really help, even like if you're trying to, you know, join a couple wires together or something. It's really nice. These things really come in handy. As you can tell, I've worn out the clips and I've replaced them with other ones, and there's two different sizes and everything else, but it still works and I still use it all the time. Now, a step up from that would be an actual PC board holder like this one, and I'll have to raise the camera to get it into the shot. So you can see here that this is just a couple of, you know, a base with a rail on it, and you can loosen this and you can slide these two pieces back and forth, and there's a couple of little ridged jaws, and one of them, if you notice, has a spring-loaded part on it. And if you want to use that, you can actually space this in such a way. Here, I'm trying to work around the camera, which is quite awkward. And just till the spring pushes a little bit, and we tighten down this little clamp. And you can see now, you can rotate this. You can tighten this, and that'll keep it from moving. It'll lock it down. And then that's even more convenient for mounting the components on there. So actually, let's turn this around. And then put this in there. And you can see we can use that as well. So just a couple different ways to hold the board so you can mount it up. Now let's look at some other things here. And I know we're taking a lot of time here to put one resistor on, but I just want to kind of go over some of the basics for those of you who are new to kit building or new to circuit board building. Just a couple of tips that I've picked up over the years. And I'm sure there's many of you viewers out there that have done this before that have a lot of better tips than me that you could share with us as well. So let me show you something else. Another thing that I recommend here, and you can see mine's kind of old, but this is called a fume extractor. And what it has in it is a little activated charcoal carbon filter. And you can see how messy mine is from using it so much, and you can just remove it. And they're replaceable. You can buy replacement ones. On the back of it, you see there's just a fan, you know, like you'd see in your computer or whatever. There's a switch on the top, and then there's a little, you know, the front has just a little hood, and you plug it in. And the fan just blows that way and just sucks the fumes right into there. Now, what you're going to find out when you start to solder, your iron will make, you know, the solder and everything will make a lot of smoke. Now, there's a couple reasons for that. The main amount of smoke that comes out of that is from the flux. Flux is, and again, here's liquid flux. And the purpose of it is it's a chemical that cleans the impurities off the metal to make a better surface for the solder to stick to. Now, solder, let's talk about it a little bit, or solder, or however you want to pronounce it. You know, it's S-O-L-D-E-R, and it amazes me how militant some people get about how to pronounce it. Where I come from, we call it solder, but really the proper pronunciation probably should be solder. But it doesn't matter. Call it what you want. It doesn't matter, as long as you understand the communication, what we're talking about. But the thing you need to understand is there are different types, but there are two main classifications. One is lead based, which is the original type of solder. The other type is lead free. Now I use almost exclusively lead based. Now there are other alloys mixed with the lead, and for instance with this one, it tells you, let me see right there, SN, which is tin 60, and PB 40, which is lead. So there is 60% tin and 40% lead. Okay, and then they make another version of this that has, you can see, we'll have the tin, we'll have the lead, but also has AG, which is silver. Now silver solder is better quality. It bonds a little bit better, it has a little bit better conductivity, it has a little bit lower tarnish, but it works, you know, they all work fine. Lead-free solder, if you're going to get into that, you need special soldering equipment. It's a higher temperature, it's more difficult to work with, it doesn't stick as easily as lead. If you have the proper soldering station and tips and everything to work with it, you can have a lot of success. But if you don't, especially if you use a lower temperature iron and so forth, it can be kind of frustrating. So I use lead. Now lead is lead. It is toxic to human beings, and as you might know, when we melt the solder onto the board and then that flux burns to burn all the impurities off, you make that smoke. That smoke contains the vaporized flux, particles of the lead and the tin, as well as all the impurities you're burning off. And if that gets into your face, or if you breathe it into your lungs, it's definitely not good for you. You know, some people, it can really flare your allergies up. You can, in enough concentration over enough time, you can have lead poisoning or any other things like that. I've worked with lead solder since I was 9 years old. I've never had any problems with it, but I don't think it's a good idea to breathe it. And even really, if you're handling it a lot, the right thing to do would be to wear some rubber gloves, some disposable nitrile gloves or something. I don't go that far, but I do wash my hands when I'm done, and I try not to handle it more than I have to, but I do handle it. So this fume extractor is very good because it will take that toxic, smoke that's coming off of your soldering iron, and it will suck it into that activated carbon and greatly reduce the amount that you're going to breathe. So you can buy these on Amazon and on eBay. Usually the price range for these is around $20 US. And I think $20 for your, to protect your lungs is definitely a good thing. Now, again, if you solder 1 or 2 times a year or whatever, very infrequently, I don't think it's going to kill you. But of course, I'm not a medical professional. I can't give you advice that way. That's going to be up to you to research and decide. But here are some of the tools you can use to reduce your exposure to it. Okay? In the day and age we live, I know if people don't make all their disclaimers, there's always going to be someone out there who's going to call you out on it. So there you go. I will use this, and you'll see why, especially with the camera. I don't like all the smoke getting on the lens and gumming it up and everything. That's the other thing. Along with my lungs, it's also protecting my camera gear. So let's turn this on, and we'll go over some tips to be successful in soldering that component in there. Now the next little thing you may want is one of these, and this is a soldering tip cleaner. So all this is some brass ribbon, or whatever you want to call it, fluff. And you can actually take the tip of your iron and just kind of rub it around in there, and you can see it'll keep it really clean. Now, here, focus. So you can see that that will keep the tip nice and clean. And the key to making good solder joints is keeping the tip of the iron very, very clean. Now, another method of doing that would be to use a sponge with water, but the problem is the cold water will harden the solder that's on the tip very quickly, and it's not as easy to clean off. And a lot of times you drag all that melted gook onto the sponge, and then as soon as you run the tip over it again, you pick the gunk right back up. This stuff here, it just seems to work best for me. It's my favorite. You can buy these again online. They're a couple dollars. And if you buy a soldering station, even the really cheap ones, a lot of them will even come with one of these included. So again, I know I keep saying money, 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 but in order to be successful at this, having the right tools helps. And you know, you're going to invest some money, but if this is going to be your hobby and it's something you're going to do, it's well worth it. A lot of these things are inexpensive and you can pick up over time, and they'll last you a lifetime if you take good care of them. So a lot of my tools I've had since I was 9, 10, 12 years old. So let's turn the fan on, and let's put our tip cleaner down here, and we're going to clean our tip. Let's get some light on the subject so we can kind of see what we're doing. And I'm going to try to work around this camera stand, which is not easy. Let's see what we can do. Now, the length of time that the tip is on the joint is called your dwell time, and you want to have a minimum amount of dwell time, but you do want to heat the joint enough that the solder can flow properly into the joint. You want to fill in that little hole, and you'll see what I do. You're going to heat the joint and bring the solder to the joint. In other words, a lot of people I notice, they'll put the solder on the tip like that, then they'll bring it down there and touch it on, and then they'll go back and forth 2 or 3 times. That's not right. I'll try to get around this camera and show you how I do. So that's it. See how fast that was? And if you notice, I don't know how close I can get this. And you can see it should be very shiny. It should kind of come up onto the wire, and you should not have any big blobs it should just be the diameter of the little pad that you're soldering to. You nip off the end, and there it is. That's how it should look. Let's do another one. So clean your tip, make sure it's clean, heat the joint, and then bring the solder to the hot joint. Here we go. And that's it. Again, this is really difficult around a camera. And you can see there it is. Now, if you recall, I was telling you you noticed the smoke that came off of it, and you can see that there's some residue around that solder joint, and that's the actual flux. Flux core solder actually has the flux in the middle. In other words, this wire is hollow, and inside of it is that liquid that I was showing you here, is inside that hollow piece of wire solder. So whenever you melt the lead or the solder, you're melting that stuff's coming out and melting and cleaning the joint. Now that will leave residue. Some types of flux are are non-corrosive. They will not eat the board or the wires or the tracks, but some of it is corrosive, especially older ones, and that's why typically don't want to leave that on there. You would want to clean that off. All right, so let's look at that real quick. So the simplest way to clean this off is just with a basic simple toothbrush. You can purchase at any dollar store, and you soak it in some denatured alcohol. I don't like isopropyl alcohol or rubbing alcohol because it has a higher water content, whereas if you use denatured alcohol or anhydrous alcohol, it's pure alcohol and it won't leave any water residue. So you just take and clean this off just a little bit. And when it evaporates, you're good to go. And that's it. It's that simple. Now, I would go ahead and solder all of this and then clean it all at once rather than do that. The other thing that I will tell you, you have to be careful. If you go back to my last video on the STK integrated circuit amplifier that we built, sometimes the silk screening, you know, the little lettering that they put on there, that ink, is not alcohol proof. And if you try to rub it with water or alcohol or anything, it'll rub those letters right off. So before you do what I just did, you may want to go to an inconspicuous place and just try it a little bit and see if this is alcohol proof or not. This board is okay to do it with, so we're in good shape. So there you go. I'm going to go ahead and mount the rest of these resistors, and then we'll come back and go to our next step. Another little note here is, as you mount these components, try to cross them off your list so that you know which one you put in. It's very easy to confuse things and put the wrong component in the wrong slot there, and if you do, it's a real pain to go back and fix, and it's even bigger pain to try to troubleshoot. So mark your parts off of the list as you install them so you know which ones you've already dealt with. The other thing I try to do, but on these little tiny 1/8 watt is very difficult sometimes, is if you look, the other thing is if you properly solder this, if you notice the solder should, let's see how close I can get again. I just can't get any closer than that. There we go. If you look, I try to put the color codes all in the same direction, but on this particular unit, we're not going to be able to do that because there's, well, we could, but it's really hard to see all that, and I'm not really going to be that particular about it. So, but if you'd like to, you can. And if you notice, the solder, like I said, flows all the way through to the back of the component. So you actually got a nice, you know you heated it up properly when the solder gets all the way through like that, because this is a double-sided board. Okay, so I'm going to go ahead and finish these resistors up. We have all the resistors mounted up here, and as you can see, I did lose one of the resistors, one of these 3.3K 1%, and I only had this size, so that's my fault. Fumble fingers. But here's the thing I wanted to bring your attention to is this. The next step is to short with solder JP9. And if you look on the board, there's a bunch of little points here, JP4, JP2, JP1. Down here is JP9, and what they want you to do is just put a little solder bridge right across it. And all the other ones, they don't tell you to do anything with. So there's number 8, they're all over the board, but those are probably going to be in there for testing purposes. But that one needs to be shorted. The other ones, I'm assuming we just leave them open. So the next thing to do is we're going to install the diodes, and let's get ready to do that. Now the next things we're going to install are these, sorry about that, are these two diodes here. And if you notice, when we did the resistors, there really is no polarity to a resistor. It doesn't matter which way you put them in, you know, one way or the other. But diodes are different. They're polarized, and if you notice, they have a marking on them. One side has a stripe painted on the end and one does not. And when you mount these in there, it does matter which way you put them in. So if we look on here, there are two of them, and they're D2 and D3 on the board. So if we look around on the board here, let's see here. We can see D2 is here, D3 is here. So if you notice on the board, they're mounted, they actually have the little stripe marked. So we want to make sure we line up the stripe of the component with the stripe of the little signifier. Now, one other note I want to give you all is there's one resistor that is not populated on the board. And if you look right here, let me move this down. There is a R32 resistor. And if you look in the list, nowhere in the list is there an R32 resistor. So I don't know if this is something that's going to come up later. I don't know. But at this point in time, I do not see an R32 anywhere. All right, so that's a little mystery we're going to have to figure out. But let's get these diodes mounted up, and we'll go from there. The next parts to install are going to be these three little inductors, and they're all the same. They're all 100 microhenry, so it doesn't matter which one goes where. And they are designated L1, L4, and L5. Now you would think L1, L2, and L3, but no, they are L1, L4, and L5. And if you look at these little markings on the board, we have L4 right here, L1 right here, and L5 right here. So those are the three places that we're going to mount them. Now, inductors, once again, just like the resistors, do not have polarity. So it doesn't matter if you mount them this way or you mount them this way, they'll work the same either way. So we're just going to get those mounted up in there, and the only reason you would care is if you really want to have all of the little stripes facing in the same direction, just for neatness. But you don't have to do that. It'll work no matter which way you install them. So let's get those installed. Now the next thing is this teeny tiny little crystal called Y1, and it is a 20 megahertz crystal. What a crystal is it's basically a device that when you apply a voltage to it, it will oscillate. Okay, I'm not going to get into big details about it, but this is going to be the device that is going to set up your reference signal that the rest of the oscilloscope is going to base its time off of. And when it is put in the circuit, it will oscillate at a frequency of 20 megahertz. And crystals are relatively accurate devices. So this is how the scope will derive its time base. Now, if you remember on the old vacuum tube DeVry oscilloscope, it was deriving its sweep signals or its reference signals from capacitors and resistors, and it was causing, and they were oscillating a vacuum tube to create your time base. This is a much more accurate way of doing it. So when we were talking about calibrated time base oscilloscopes, this is the beginning of that, of how you would do it. Now there's many other ways to do it that are even more accurate, but this is an inexpensive way to do it. But this crystal is teeny tiny. As you can see, it's really small, and it was hard to find in the parts bag. Now it's going to mount right here, and when I look at the schematic or the little pictorial diagram, I don't know if you can see that there, but they've actually tacked it down onto the pad there with some solder. So they want you to place this in there, along here, and then they want you to actually solder down the case of it. Now the problem is if you heat this up too much, you can damage that crystal inside there. So you're going to have to be very, very careful. I would clean this with a Q-tip or with a swab with some alcohol to make sure there's no oils or dirt on it, so that as soon as you touch the solder on there, it'll solder on without overheating and damaging it. So we're going to get this held down on there, and you're going to see this is not the easiest thing to do. Again, it is not, there is no polarity to it, so it is non-polar. It doesn't matter which way you put it. And the way we're going to start this is we're going to have to hold this down, and you can see they've already tinned these two pads, and we're going to heat those up, and each wire will go to each pad. And that's how that'll go down on there. So it's going to be a really tricky thing. I'm going to do it off camera because I can't work around the camera on something tiny like that. To hold it in place, for starters, I'll probably just take a small piece of tape, like this kind of tape here, clear tape, and I'll tape it into place and tape the wires into position, and then once I tack them in, I'll remove the tape. So just like I said, this is very delicate, so I don't want to damage it, and I kind of just wanted to give you guys a little heads up on that if you decide to build one of these too. Alright, you can see I got this in there. It was kind of a touchy job, but we have these two little pads tacked on here, and then I just kind of ran a little bead along there. You can kind of see it. See how shiny that is? That's how a good solder joint should look. It should kind of be concaved in there, and it should be real shiny when it dries. So we got that in. That was a little bit touchy, and so now we're going to move to the next component, which according to the list is a USB socket J1, and I'll cross that one off the list. Here's our USB socket. You can see it right here, and when we flip it around, you want to make sure that it's very flush to the board, and these four little ground tabs are not just grounds, and I'm off camera again, are not just grounds, but they also serve to tighten the connector to the board. Those are strain reliefs, so you want to have those soldered in there well, so that plugging in and out of that with the USB connector, you don't eventually loosen up the wires and cause the tracks and everything to crack in there. Getting that solidly put on there is very important. So let me get that tacked in, and we'll go from there. I have this mounted in now, and you can see this is kind of how you want to get it. Make sure you have, again, make sure it's shiny, the joints are shiny. You don't want any little solder bridges. It's really difficult to get in here, I'm finding out. You really need a small tip for your iron. And they do make small tips for the little plug-in pencil type irons, but usually you have to purchase those separately. The ones that come with them are too big. I would not recommend trying to use a chisel point or something like that. Use a tip that's kind of pointy on the end, or I actually use these little curved tip types here, but you don't have to have that. They make any number of pointy tips that you can get, you can see, and any one of those would work just fine. But you definitely want something that can really get in there tight, because this is like I said, these they made this board really small, and they made these joints really close together. So that's the one thing I will say, if you're a beginning person in electronics, this is definitely a good thing to hone your soldering skills, but you will have to be very patient and very careful, and take your time on it, because it's very easy to really kind of mess this up. Okay, so our next part to put in looks like we're going to do some switches, the tactile SW12, and then we're going to go on and do the capacitors. So let me get the rest of these in and get all these caps in, and then I'll be back. It's going to be the same process as the resistors. We're going to identify the parts, and then place them on the board. Okay, before I go ahead and put these capacitors in, the first thing I wanted to do was go ahead and sort them out and separate them and kind of make sure that we have the parts that we're looking for. And we do. And part of this, to identify these, you can look at the numbers on them and separate them by the number of them that you see. But just so, you know, to help you guys out, if any of you are going to build one of these, there are 12 capacitors that are the larger diameter ceramics, and they have the number 104. Now, I don't know if you can even see that. It's so faded on these that you almost can't even see it. But they all say 104. And the way that they're marked as a 0.1 microfarad capacitor, you can see. But the 104 ceramic capacitors are identified in picofarads. So 100,000 picofarads would be 0.1 microfarad. So that 104 is telling us that. It's a 1, a 0, those are the first two digits, and then there's 4 more zeros after that. So that would be 100000, which is 100,000. So that's how you can identify these. So for instance, there's a 300 picofarad. So that should be a 301 is what it should be. A 3, a 0, and 1 more 0. So if you look through here, there should be some 301s, and there should be 2 of those. Here's a number 1, nothing else on it. That's a 1 picofarad. A number 3 for 3 picofarads. And a 1.5, I think that's what that says. Let me look. A 1, let me get it over. I can't see. Yes, a 1.5, which is 15 picofarads, which we should have 2 of those. And then this one here is a film capacitor, and it is also a 0.1 microfarad. So they're all separated, and then 120 picofarad, which should be a 121, which is this one right here. So now that they're all separated and they're all present and accounted for, I'm going to go ahead and get those mounted onto the circuit board, just the same way as we did with the resistors. So when I get that done, I'll be back. Now, one other quick thing I wanted to go over with you guys. I was looking through this, and if you notice, if you recall on the last scene here, I found, let me get this straightened, that this right here, this R32 resistor, is not listed anywhere in the parts list. It doesn't exist. There's a few things that are missing, and if you look through here, some of these things in here say optional. And what some of this is for is you can get one of these with a lithium-ion battery in it, and it'll have a built-in battery and a battery charger. This particular kit that I got does not have the battery with it, so I don't know if they sell that version. I haven't looked. We could probably check that. But this one is going to operate off of an external USB power supply, so you can use this cable and plug it into your USB port, or you can even plug it into one of those little battery packs, USB battery packs, and run it off of that. So that's why there are some components that aren't there. Okay, let's get the caps put in, and we'll be back. Our capacitors are all in now, and that's good. So I've crossed those off. Now the next thing we have to do is these little components here, the buzzers, and then the electrolytic capacitors, and then this one connector. And once I get those all in, let's see if it's focused. Once I get those all in, we'll be ready for these bobs, or I think that stands for board on board. So I'll come back when I get these other components in. I now have all the rest of the components mounted up on the board for the most part. And now the next thing we're going to have to do is mount these, what they're calling BOBs, B-O-B, which I believe stands for board on board, but they don't really tell you what they mean. But here they are. And they have a little mounting jig that we use. You just kind of clip it onto the side like this, and that supposedly will hold it 90 degrees on the board while you mount it. So we're going to have to do that. And the first thing we're going to do is we're going to go through and we have to identify each of the boards, and then we have to identify where they go with respect, to that. And you can see down here they give you a little procedure how to go ahead and use that little jig to mount the parts up on there. And really all we're going to do is build these little solder bridges by soldering them right where the two tabs meet. So if you look down here, we have these little pads, and the idea is to get the board across these pads, hold it at 90 degrees, and then tack it down all the way across. So yeah, it looks like it's going to be a little bit tricky once again. I will tell you that some of these pins were not very fun to get in there, especially these little switches here. These tiny little pins are so small. Let me see here. Just a little word of warning. They're so small and close together that when you try to solder them, it's very easy to touch an adjacent component or to build a little solder bridge or something. So you can be very, very careful when you do that. The other thing you need to be aware of is you need to clean off all the flux in there with a brush and some alcohol, and be very careful. Like I said, it takes time. You have to be patient and go through it very carefully, and if you do, you can get it all in there. But again, I highly recommend, the more I get into building this kit, the more I recommend you really need to have a very small tip on your soldering iron. The chisel tips that come with most of the ones you buy just isn't going to, it's going to be too big and too awkward, and I think it's going to cause you to have some issues when you try to actually use it. So just a little word of warning, at least what I'm finding as I try to do it. So now we're going to try to mount these boards up. Once I get them all identified, I'll get the first one on there and I'll kind of go over with you how I did it. Before I show you where I'm at with mounting these boards, first thing I've noticed is they've made a mistake here. It's not a bad mistake, I guess, but this board right here is the on-off board. This is the power switch board. Okay, then these have like a couple of little transistors and some small components. That's all it is. It's for the on-off switch. And if you notice, these two boards are identical. And even if you go through, they're so tiny to work with, and you look at the part numbers on the back, you can see that they have the same part number on them. Okay, so they're both the same part number, which means we got two of them. And we do not have the Bob 2 board, which the Bob 2 board is the battery charger board, which we should not have that because we do not have the battery option on this one. So I get that. So I think what really happened was they just stuck an extra one of these boards in here. So you may or may not get the extra board. Probably you won't when you go and order one of these for yourself, if you do. Right now the only thing I have left is this board, which is the negative power supply converter board. And like I said, just one of these on-off switch boards, and then I'll be all done. Now let's move over here and I'll show you what I've done so far. So here's the first two standoff boards here. I'll just call them standoff boards. And you can see you just kind of put them on there, and I will tell you, this thing here is very awkward to try to hold. It's easier to just hold it down with your finger and tack it with a piece of solder, you know, the one pin, just enough to hold it, and then go through and finish it. Now, I will tell you, I've been soldering for 40 years now, realistically, and I can tell you I have very good equipment. I have the right tip, the right temperature, everything, and in spite of all that, I even had a difficult time. I had to take my time and go very, very slowly, be very, very careful, and you can see I was able to get those all in there. This thing doesn't like going too close, and you can see I got them in there on both sides. I was able to get them soldered, and this one's the same way. But you can see, I mean, it's so hard to get in there. Knowing what I know now, even I don't care what the manual says to put these in order, in the order of which they're listed. Please install by the order given in the parts list. That I do not agree with. Before you get the components, especially like this buzzer, the capacitors that stand up off the board, anything that stands up around these pads here, I would recommend not. Like, these two things are going to become problems now trying to get on this side. I would recommend not putting any of these parts in before you install these standoff boards. So hopefully you'll go through and watch this whole video and come to this part before you follow along step by step with me. And I'm going to try to put a couple of notes. I'm going to do a little opening credit maybe to this video before I go into what originally would have been my opening credit. So anyways, it is possible to do, you can see, but I would definitely call this a more advanced soldering job than a beginner's kit. And that's unfortunate, because this is, up until this point, has been a really good beginner's kit, with the exception of that. But again, I think you can do it, but do not mount these stand-up parts first. You can always go back and put these in after you get this on. Okay, and again, I could have taken these off, but I didn't want to try to desolder and make a mess and everything. So I have the tools to work around it, but it's definitely taking me a lot longer to get it. So let me get these last two boards mounted up, and we're going to be really close to being able to test this thing out. Well, I had to bring out another light, as you can see over here, and then this one over here, and lots of light later, and lots of very finicky soldering later. These are all mounted up, and they look pretty good. To borrow a phrase from YouTuber BigClive.com, who I have a lot of fun watching his channel. If any of you have ever seen him, he does some really great videos on some things. This job was futchery. So yeah. Anyways, this is all together now, and we are to the point where we're ready to test this out. Now, here's another thing. They want us to perform a power-up test as described on the reverse page, and then do the assembly following the test. So there's parts in here they don't want in, which I already put in, these switches, but I did not put in the LCD or any of that stuff. But I will put those in. I will put the LCD and everything after I do power up test 1. I just want to make sure everything's working. So I'm going to test it out. If it looks good, then I'm going to go ahead and mount up the LCD. These instructions are very confusing, and you have to really look at them carefully, because it doesn't go into a whole lot of detail how to do this. it wasn't until after I put the switches in that I read this red part that said, you know, they should have put this stuff. It's confusing. Anyways, you're going to want to follow this verbatim, except for, once again, like I said, you do not want to mount these capacitors here, this one here, these connectors you don't want to mount, this buzzer you don't want to mount, this transistor you don't want to mount. I would leave all those components out, even though it tells you to put them in up here. I would not do it until I get these standoff boards mounted up, so you don't end up melting things and trying to solder around corners and crazy stuff like that. So hopefully this seeing this will help you all out to be a little more successful in putting your kit together. So now I'm going to go ahead and do the test, and we'll be right back. Okay, so I did the little test, and it failed the test initially. I couldn't get this this first test to pass. It got all the way down to this part, and when you pressed S12, I couldn't get the LED to light. And I went on a wild goose chase with what it tells you. And really what the problem ended up being, I don't know if you can see, but this chip, this is your main processor for the whole machine. It was not, one of the leads was not soldered perfectly. So what I had to do is I had to get the heat gun and just put some flux on there and go around it and re-tack all of these surface mount tabs down. So the way I was able to find that was kind of by moving this around, you know, with my finger. I could get the light to come on and off. So now that I have it all done, it's perfect now. It's working good. And this is kind of what it should do when it's working properly. I just went ahead, and the only thing left to do was to put the LCD on, which you just slide it over the pins and tack these all in here, and you're good to go. So you plug your USB power into it, and let's move some light out of the way. Hit the power switch, and there she goes. Very good. So it's working. Now the other thing is, if you get an LCD, or if you get the backlight but you don't see a display, there's a little adjustment back here called contrast. You can kind of see it, and it's just a little pot, and you adjust that until you get a good image on the display. So this is ready to go. I'm going to go ahead and put the back on it. You can see it's all finished now. And I'm just going to put the back on it now, and it should be ready for us to test. One last thing I forgot to show you before I put the cover on is these two jacks go in last but not least, and they just go in with these little wires. Now this gray wire came with the kit, and they tell you to use it to attach these. And for these ones, they just tell you to cut some end leads off of the resistors, you know, use those and just use that. And I actually slid a little piece of heat shrink over there just in case. And I did make them a little bit looser so that if this flexes a little bit, it's not going to crack or break or whatever. So ready to go and ready to put the cover on.